Good evening and welcome back to the Johnson Space Center for tonight's mission status briefing after a busy day in orbit. With us to discuss all of the latest on Atlantis' flight to the International Space Station is Kelly Beck, the lead STS-117 Space Station Flight Director, Keith Johnson, the lead spacewalk officer for this mission, Mike Suffredini, the International Space Station Program Manager, and John Shannon, the Deputy Space Shuttle Program Manager and Chairman of the Mission Management Team. And we'll start off with Kelly.
Well, good evening, everybody. We had a very successful day today. The crew started out their day with doing preparation activities for the spacewalk, as well as beginning the retraction of the 2B array. While Pat Forrester and Steve Swanson were getting suited up with the help of Danny Olivas and Sonny Williams, we had Commander Rick Sturco, Jim Riley, and Lee Archambault. We call him Brew, so if I slip and refer to him as Brew, you'll know who I'm talking about. They started the retraction of the 2B array while the crew was getting suited up. That actually went better than we had anticipated. If you recall, we were expecting to have problems with the panels folding properly and getting some of the guide wires hung up that would cause us to have problems with the retraction. We actually got further than we anticipated without the help of the spacewalking crew, and we got it retracted about 25% of the way before the crew went out the door. Then we proceeded on, and during the spacewalk, Pat and Steve then got up to the work site and assisted with the retraction. And with their help, we were able to get it to just not quite halfway retracted. They went out and helped us clear some of the problems that were causing the array to hang up and not fold in properly. So that went really well for us. Keith's going to go into more of the details of the spacewalk, just sort of the highlights. We did get further than we had anticipated with the 2B retract. We didn't get quite as far with the solar alpha rotary joint prep tasks, quite as far as we had anticipated, but overall we got a lot done and it was a very successful EVA. Crew they were outside a little over 7 hours of spacewalking time, so a lot of productivity from the amount of time they were out there. Today, the mission management team did make the decision that we will be doing the OMS pod blanket repair activity on the next spacewalk. So what the crew will be doing tomorrow primarily is getting prepared for that EVA, doing some procedure review and having conferences with us on the ground to go over those techniques and the plan. And we'll also be trying to do some additional retraction of the 2B array to see how far we can get without further assistance from the spacewalking crew. So on that third spacewalk, our plan would be to go ahead and repair that blanket, and then also to try to do some additional retraction of the 2B array. So all in all, very good day, and I will hand it over to Keith to give you some more details on the EVA.
Okay, thanks, Kelly. We started off the EVA knowing that we had a problem with the leader, and I have one of the leaders right here. There is a spring that's at the base of this leader that broke while it was on orbit, and that was noticed by Mike Lopez Alegria on a previous mission. And when the spring broke, it allowed this piece to flip backwards and forward. What we were concerned about was that if it had a piece of spring at the bottom, it could get folded in, and then when we compress the solar array blanket during the retract, it could cause damage. So we were concerned with that. A couple days ago, the crew took pictures of this, and they noticed that the spring was in fact attached at the bottom, which was the condition we knew that we needed to cut this with. So we reconfigured the tools to make sure we had the pair of scissors and the correct tools to get this in position and to cut it off. The crew was successful in getting that piece removed. They put it in their trash bag, and they brought this piece in with them, so that's now out of the way. After that, we also saw from the same pictures from Mike Lopez Alegria that the flat connector circuits that are on either side of a solar array blanket had tended to fold the wrong way, and the problem with that is that they could poke out of the solar array blanket when we're trying to compress it. So we had a tool that we developed on the ground, and you can see they call this the hockey stick, and then it's kind of obvious where its name came from. But this is some Teflon sheets that are Kapton taped together. We're worried about open circuit connection and causing a shock hazard. So this tool is made completely non-metallic. This was a tool similar to this was built by Sunny Williams on board the space station. We sent her up plans to build this thing. She constructed it. The nice thing about this tool was that both crew members had an opportunity to use it. Steve Swanson came out the door with it, and he went up and poked at it while Pat Forrester was getting onto the arm. He was able to get the two flat connector circuits that were closest to the mass canister. And after that was done, he handed the tool off to Pat Forrester. Pat went to the outboard one and poked that into position. We continued the retract to make sure that it's in a good position so that tomorrow we can continue the IV retract that Kelly talked about. So we retracted enough bays that we think we're comfortable to get quite a few more tomorrow. So that's what that tool is for. Once the crew got done with that, they went back to the airlock and hooked up on the tethers that we headed out to the S3, S4 truss element. We started working on the Sarge brace beams. These beams changed the load path from a launch load to an on-orbit load. While the crew was out working on this, they found that it was a little bit difficult to get them in, but through some teamwork and some words from the ground, they got it into place, and so all 4 of the brace beams are in place. After that, they went on to install the second of the drive lock assemblies. We had a little bit of an issue trying to get that in place, but we finally got it where we want it, and it's now engaged and covered up. After that, they worked on launch locks. They got the remainder of the launch locks that need to be removed from Sarge. And the last task that we had hoped to do were the Sarge launch restraints, but we saved those for another day. And that's the completion of the EVA for today.
Mike.
Well, good evening. It's good to be here this evening. We talked a little bit about the work we had in front of us last night, and the team, it wasn't obvious when we're not doing things outside or deploying arrays. It's not obvious the work that the team is going through, but there was quite a bit of work to get the S3-4 truss power system up and running so that we could hand over the remainder of the loads on the 2B array that we then turned around almost immediately this morning and relieved the tension on the half bay retraction I talked about last night. And all of that went very well leading up to that point, and we did relieve the tension on the array this morning shortly before 6 o'clock. And then, as I told you, we went right into about 10 o'clock after the crew was up and ready. We went ahead and started the retraction process. And Kelly's talked to you a little bit about that. But I will tell you about an event that occurred right as we were beginning the retraction this morning. As you know, last night Joel talked to you about the Russian segment computers having both guidance, navigation, and control computers. There's 3 of those, or they're all redundant to each other, so any one of the computers can do the job. And then we have command and control type computers, also of which have 3 computers. We call them lanes, and any one of which can do the command and control function. And then we have light computers on the U.S. segment that talks to these computers. And so when we last left our heroes, we were on 1 lane each, and the flight control team was off doing the work we talked about, getting the system configured, and the crew went off to bed. During retraction this morning, for reasons that are not clear to us at this time, we lost both of those computers, and so and currently we're in that configuration. The guidance, navigation, control computers and the command and control computers in the service module are not functioning. Our Russian colleagues tried a number of techniques to try to recover the computers and were not successful. They have since stood down and gone off to meet with amongst themselves and with our colleagues to try to come up with some recovery steps that likely will be attempted when we start having ground passes over the Russian segment. As you probably know, the majority of the command and data that gets shipped back and forth to the Russian segment from the MCC occurs over Russian ground sites. The majority of those occur on the early orbits. We talk in terms of orbits. There's about 16 orbits a day, and so in the early orbits we typically come over the Russian ground sites. We cover quite a few of them, and then later in the day, in the higher numbered orbits, we don't cover the Russian ground sites any longer. And so our Russian colleagues will wait to start coming over to the Russian sites early tomorrow morning and probably begin the process of attempting to recover those computers again. So where does that leave us? You might be interested to know. Well, the guidance, navigation, and control computers allow the system to control the attitude and provide propulsion if necessary with the Russian thrusters. Without those computers, we can't get attitude control from the Russian system. That's not a problem for us. The CMGs, in fact, are controlling the attitude and done a fine job today. They're very low momentum on the system, and they've handled the stack very well. In addition to that, if they saturate, and you saw us do this yesterday, we can hand over to the shuttle system, and they can take care of the attitude control function. And in fact, we are working techniques to hand back to the CMGs from the shuttle verniers. We think we have a technique for that as well, and so that's not an urgent situation, but clearly we need to get this resolved before our shuttle friends leave. Command and control computers control things like the electron that provides oxygen, the Vosduke that scrubs the CO2, the humidity scrubbers, and the water processor. Those are the primary systems that they control. Things like the lights, the fans, thank God the potty, all of those things are working, and so the crew's in good shape because we have the seeder up and running, which by itself can handle almost 9 crew, and of course we have plenty of LIO for the balance of the crew, so that's not an issue. We have plenty of oxygen. Before we ever took off, we had done an assessment on the amount of O2 we had without an electron operating at all, and we had 56 days, which of course is way more than we need. So that's fine. We, of course, scrubbed the condensate on the U.S. segment, and that's fine. And we've got plenty of potable water for the crew to drink because every day we get a couple bags of water from our shuttle friends. So we have plenty of the resources, and so we have plenty of time to sort this out. We have, in the history of the program, often had these computers go down 1 or 2 lanes. It's not uncommon to be on 1 lane of each system and wait for the last one to finally give up, and then the whole system reboots itself and starts back up. And of course, what's unique is when the system went to reboot itself, it wasn't able to do that. We are in meetings. In fact, I came from one to come to this meeting, and I'll go back to it when this is over. Discussing techniques and options for trying to resolve the issues that may be causing this problem. There's a number of things you can imagine that we're looking at. Everything from the external environment, the radiation environment. Have we had any electromagnetic storms lately? The answer to that's no, unfortunately, or fortunately, depending on how you look at it. We've looked at the plasma environment. You know, we added a new truss. That's more surface area. We also added arrays, which also affects the environment, the plasma environment around the space station. But the plasma control units are working fine. In fact, they're hardly working at all, which implies that the environment is down where we would expect it, even though we've added this new element. We're looking for any new source of EME or EMI that we're not aware of. Of course, everything that flies gets tested for that before we ever fly it. The one that folks are starting to look at and scratching their heads a bit about is we did, of course, add another power source in the form of the S34 truss, and so we're off to look to see if there's anything about that power source that may have affected the ability, that may make it slightly different for reasons that aren't clear. The power quality coming from that element that may have affected the ability of these computers to operate correctly. And then, of course, on the Russian segment, there's a number of things our Russian colleagues will look at as well to see if they can figure it out. So we're working through those options tonight. We'll begin in earnest tomorrow morning to try techniques to recover these computers. I fully expect us to be able to do this. I'm not thinking this isn't something that we will not recover from. But in the meantime, being NASA and the fact that we try to do everything we can to protect every option, we are looking at options to extend the time that the shuttle guys stay with us, just in case we'd like an extra day or so. We can't extend it much, but we're certainly looking at that. We're also looking at a number of different options, how we conserve per prop if we decide we need more attitude control help from our shuttle colleagues than we had originally planned. So we're looking at how we manage the propellant, the O2, and any of the other resources necessary to see if we can extend a little bit longer if we need to. So that's the position we're in today. The vehicle's fine. And like I said, tomorrow I would expect this time tomorrow night we'll be telling you about our steps that got us at least one lane in each system up and running. And if not, how we continue to lead toward that position. So that's where we're at today. Overall, the ISS has done very well. As Kelly has mentioned, her team has done a fabulous job of getting us where we are today. The systems on whole have worked very well, and so we're very happy with the performance of the S3-4 truss as we brought it up. And as she said, from a retraction standpoint, I sat here and told you last night, and even though Joel's line said that it was going to be retracted by 1:46 today, we told you that the plan was set up to give us several days to retract the arrays, and I suspect by the time we're done with our EVAs, we'll have it in the box. And so from our perspective, the mission's gone very well in that respect. And that's all I have. Thank you.
John.
Okay. I've been coming in and telling you how the MMTs have been going, the mission management team, and we met for about 4 hours today. It was fairly long. We spent 2.5 of those hours going over the operations and spacewalk engineers' plans on repairing the torn OMS pod blanket. And we did pick one repair method. All of these repair methods were assessed by crew members that had been out on spacewalks before. And the method we came up with was they were highly confident is how they rated it, that it would be successful and something that could be done. We also took a look at our testing, and I'll talk about that a little bit more. And it also was supporting very well. So we decided that the best course of action was to go ahead and try and add it on EVA 3 on Friday, and that's what we asked the ops team to go look at. Let's go to the first picture. This is just to reorient you. This is a picture that was taken from space station. It gives a little better view of the OMS pod blanket, and you can see not just the little corner, the little 4x6 inch triangular piece that is up, but the blanket right next to us. To it, the one that's closest to you in the picture also is pulled back a little bit from the tile, and we're going to address that as well. The repair method that they chose, that the MMT agreed with, the first step is that when the astronaut gets out there on the shuttle remote manipulator system, they'll pat down the blanket. And go to the next chart, please. And they can either use their gloved hands, or we have a tool. It's actually a scraper tool that you would use if you were going to do some other type of TPS repair, to go ahead and tamp it down. These blankets are very formable. If you remember the other day, the memory on that blanket, it will take the shape that you put it in and pretty much stay there. So we think we'll be able to push it down, and it'll stay in the slot very well. The next step that the astronaut would do is we're going to put a double row of staples. Go to the next chart, please. At the bottom of the blankets, you'll attach them with this medical stapler, and then you'll pull it together. And at the top row, you can run a row of staples. These are not your average office supply staplers. I have one here. It's called a medical stapler. Each one of these holds 15 stainless steel staples. That's hard to say. And it's just actuated by pushing down on this, and just like you would think if you were trying to close a wound, you don't have to use very much pressure. As the staple goes in, it kind of has hooks that go in to into the blanket in this case, and provides a very, very tight bond. A normal staple, you would think you can kind of bend it and twist it around. These staples are more like little fish hooks. They're very hard to change their shape. And they're also stainless steel, so that provides you quite a bit of not just strength but heat resistance as well. So after the crew staples it and attaches one blanket to the neighboring blanket, they're going to attach it to the tile that's directly in front of it. Let's go to the next one. And they will use two things. One is a nickel chromium pin that was developed in tile repair application. If we had a big gouge in a tile, we'd take these bags of insulation and pin them to the tile, and then put this overlay over the top of it. Well, we use those pins because they're heat resistant, and they're very good at going in tile. And if you can come back to me, I'll show you here. Here's the pin. It's just a very straightforward piece of wire, but it's very stiff. It's kind of hard to bend. And what they'll do, we have a little mock-up over here is they'll take this this dental tool. It's just a piece of metal with a little probe on it. And I'll wait for the camera over here. You can go over. There we go. This is just the tile, and you can see if you try to, the pin, it's kind of hard to push into, and I'm kind of doing it. But what the crew will do is they'll just take this and they'll score the tile a little bit, and it's very easy just to push right in, and it stays pretty well. So with that tool and that pin, we think we'll be able to very easily secure the front of the blanket to the tile and not have any gap in there to let any airflow get in. If for some reason we're surprised and the blanket is not in as good a shape as we think it is, another method was suggested, and this is the stitching repair method, where they use that long curved needle that has some stainless steel wire attached to it to stitch it up. I think the likelihood of actually having to use this is very low. All of the astronauts that tried using the stapler were highly confident that it would work, but this will be a backup capability for us as well. You go to the next chart, just shows a little better picture of that dental elevator, which is just a metal probe that we can use to put a hole down through the blanket or a small hole in the tile to push the pin through. We spent a great deal of time today talking about the test schedule and what we want to do to prove to ourselves that what we're going to do is going to be effective. Let's go to the next chart. The first thing we did, and this is all complete, is the pull test. We took the different options, one of just pushing the blanket down and leaving it, not doing anything to secure it, the staples with pins, the stitching with pins, stitching with staples with pins. They did all of them. And they put a small bladder underneath the blanket and would pump it up to see how much force it could take, and that was supposed to simulate air getting underneath the blanket and pushing it up. All that was done. It was the team was very confident that the staples with the pins would meet our objectives. We do have a mock-up going to the ArcJet facility, and that's going to be tested late Thursday. And the reason for that is we have these stainless steel staples and these nickel chromium pins. They will see an environment of up to 1,000 degrees. It'll be somewhere between 700 and 1,000 degrees. So we'll do the repair on a blanket with the real staples and the real pins, put it in the ArcJet, and run it through a simulated entry profile. Because even though stainless steel melts at about 2,500 degrees Fahrenheit, and it won't see near that, it will degrade the metal's capability. So we're going to put that in the ArcJet, we're going to put it through an entry environment, and then we're going to take it over to a wind tunnel at Texas A&M and hit it with the dynamic pressure that's expected during entry and see how the degraded metal in the staples and the pins holds up. We expect it to be very successful and not to have any problems at all. But that's the wind tunnel test that we're going to do. Then if everything we did was wrong, or if for some reason we weren't successful and we got heat down there, I've said a couple of days in a row that we don't have very much understanding of that graphite epoxy honeycomb, what heat does to that. So we're going to go into our radiant heat facility, and we're just going to heat that graphite epoxy up, a cavity about the same size as we're talking about here, 4 by 6 inches. And we're going to test it just to see the impact on that honeycomb epoxy. It'll be some good data to have. I don't think it will be relevant to what we're going to see on entry. The only other real topic of discussion that we had was, after we decided on EVA-3, was the discussions about the attitude control system on the space station, and Mike and his team briefed us, and we just talked through that and talked over different options for potentially staying an extra day and what that would take, and that was about it for the MMT today. Rob?
Thanks, John. Okay, we'll take questions. Jeremiah, let's start over here with Bill Harwood, and we'll work around.
Bill Harwood with CBS with 2 from Mike. I just need to bound this to make sure I understand what the issues are. What happens, just so I know, I think I do, but just do I know, what happens if you don't get them up and you have to leave? What does that do? And the second question is, when would you have to make a decision about a Group C power down or something like that to get the extra day? How long can you go before you have to decide something? Thanks.
Let's see, I'll do the second one first. We're deciding that now so that we have a chance of getting the extra O2 we need. So within the next few hours or the first part of tomorrow, I expect we will find ourselves looking at reducing some of the loads on the shuttle in order to get us the additional O2. The latter is we have to have propulsion of attitude control even with CMGs. That's the CMGs do a great job, but occasionally they get saturated. And when they get saturated, then we need propulsive attitude control in order to recover. The other, of course, need for propulsion is to make sure we can do debris avoidance maneuvers, to adjust our orbits for dockings. There's a number of reasons why we need propulsive attitude control and translation capability. So that's a requirement of the ISS, and so we have to have that capability. Does that answer your question?
Oh, it did, but it did. But if you would state what if you don't? What do you mean when it's a requirement? Does that mean you have to unman the thing? I mean,
well, you know, we'd have to talk about all that. There's a lot of techniques we've created along the way as we've flown the ISS. Recently, we did a maneuver all on CMGs, which we hadn't done in the past. Generally speaking, when we used to use the CMGs for maneuvers, which we've done, we start a maneuver, and when we get to the end, we needed the jets just to stop us. Basically, the CMG saturated. Well, we recently maneuvered the space station, in fact, 2 or 3 times, I believe, where we started the maneuver, did the whole maneuver, and stopped the maneuver all on CMGs. So we would look at all types of techniques to buy ourselves some time. We can always, like any critical problem, we can always leave ISS if we need to. Whether we would leave the ISS in this situation, I don't know, because we're always in a better config if we can keep the crew around to help us out. You know, I know what you want me to say, but I would tell you I haven't worked through it. I do not expect that in the next 3 days we won't be sitting here telling you that we've got these computers back and we've kind of understand why that occurred. I just don't see that as being a scenario by the time our shuttle friends leave. If we are in that position, we have an option to depart. We always have an option to do that. This is not the only scenario that we could find ourselves doing this. There's a number of different critical situations that could occur where you'd have to unman ISS, but I don't expect this to be one of them. But that would be the worst case scenario.
Mark.
I'm Mark Crow, Houston Chronicle. I think I'm following up on a couple of points here, but is this a software problem or a hardware problem on the shuttle where there are on the station where there are spare parts? And then I have a follow-up to that, please.
If I knew that, Mark, I'd be sitting here telling you how I was going to fix it.
Okay, thank you.
I guess I could tell you, this appears to be, I would tell you from my knothole, this appears to be something that has occurred over the last few days. So that would tell me that all 3 computers didn't just all have a hardware failure, although we did suffer something similar to that several flights ago on the ISS side. It appears to me that something has changed in the environment. Either something in the environment or the source of power now to these computers is different coming from S3-4 that for reasons that we do not understand. It could potentially be software, although we have not uplinked a software change, but perhaps something's happened to the software. We can always reload it, and of course we will talk about that option. I'll tell you, our Russian colleagues believe it's the power source. That's the latest theory they have. They've suggested to us that they have suggested that perhaps, and we will look at this, perhaps we could disconnect from, we will stop feeding them power and let them just use their own internal power to bring up their computers and see if that solves that particular problem. They cannot run on their own power because of all the systems that run to handle the entire crew. We have to feed them a certain amount of power to keep everything running that we need to run. So eventually we'd have to work through that. Another option that we're working through is just stop feeding them power from S3 truss, which is maybe the first thing we'll try. But we're still sorting through our plans. But I don't think the hardware has magically, all 6 computers, which are all similar, I don't think that's the problem. I would suspect it's either possibly software or some external cause that we've got to sort through.
And I believe at some point, would not the shuttle, which is there to provide attitude control, I guess, through this situation, does it not run out of prop, and therefore it's not that useful for attitude control? And when does that happen, if that's a factor?
Well, it's extremely useful because we don't ever require any prop-related system to provide attitude control all the time. We're on CMGs right now. We've been on CMGs for the most of today, if not all of today. Have we been on CMGs? All of today. So the day before yesterday, when we were deploying arrays, it had to do with the amount of change in momentum the CMGs couldn't handle, the arrays going out, and what set of thrusters we used to control the stack, because certain thrusters point a certain direction, and depending on which array was going out, one was worse. So at one point we had the Russian segment backing up CMGs. In the other case, we had the we had the shuttle with verniers actually doing the attitude control. At one point, we went into free drift and we just stayed there for a little while. All of that was based on major momentum-changing events. The next couple of attitude maneuvers or momentum-changing events are the Sarge. When we first activate the Sarge, obviously until the restraints are done, we won't be moving the Sarge, so we've got a couple, 3 days before we even have to talk about that now. But we were going to hold off on that. We don't need to activate the Sarge right away, so we were going to hold off on that. The other one is we had to do an attitude maneuver, do a dump. We'd planned to do a wastewater dump tomorrow. We postponed that for a little while we sort through this. So we don't have anything that requires us to do attitude maneuvers, and therefore the CMGs should be okay. If the CMGs have a problem, what typically will happen is they'll saturate. In this case, the shuttle will take over the load. It will take out the rates. It'll settle it all down, and the CMGs will take back over. So you're absolutely right. And we've gotten some numbers about how long it would take, and we're often working with our shuttle friends to pick attitudes and thruster combinations to get us as much time as possible. But we can't have 24 hours of propulsive control every day, and shoot, I can't do that with the space station either. That's why the CMG's there. And the CMG, that's typical. CMGs are typically the device that are holding attitude in space station, unless we're doing major events like attaching solar arrays, deploying solar arrays, attaching trusses, stuff like that. I don't know, John, if you wanted to comment more or not.
Let's go to Gina and then Todd. Gina.
Gina Sinceri, ABC News for Mike. Mike, describe these computers for me. And they're in the Russian segment. Describe them for me. And is this like booting up my laptop here? What's involved? And then, have you ever seen this before, this kind of failure?
Let's see, I don't know how to describe these to you. Nothing we do on space station is like booting your laptop, other than booting our laptops, which we do have a lot of on space station. So I've never actually commanded a Russian segment computer before, so I don't exactly know the steps you take. But it's a mill standard type computer. It's actually a European-built computer that was provided by the Europeans years ago as part of the process of building up the service module. But it's not any different than any other computers in general. They're not exactly the same as the computers we have, but they're very similar in capability. They're Western-style computers. But they'd be just like, if you saw one of our computers, it's just a black box with big connectors on the end. It doesn't look like anything. And the actual steps I don't know, but they're fairly simple. You send a command to it to go off and reach into a certain part of memory to activate a certain piece of software. A lot of things your laptop does for you, we would do manually. Just tell, go get this code, go activate this code. Then the software starts running, it brings things up. And then we generally have to reconfigure it. We need to tell it what configuration we're in, what to expect, things like that. But it's not typically a lengthy process. And in the case of the Russian segment, whenever we lose the third lane, so I'll start by saying rarely do we have all 3 lanes up on either the guidance or the command and control. They lose sync over time, and then that one stays out, and then the 2 that are remain will lose sync, and then one will be up. And then when that last one loses sync, it's automated. The process of bringing them back up is automated, and so the system goes up, it reboots all 3 of them, they all get synced back up, and then they move on, and then the ground has to do a few things to tell it again the configuration of the ISS. But it's a totally, if you're letting the system do it, so you can do it totally hands-off. This is what did not occur. This is probably the most interesting event. It wasn't that we were down to a single lane as much as when we lost the one computer, the final computer of the 3, the system went in to reboot itself and tried 2 or 3 times and was not successful. And so that's probably what's unique. So I would tell you that in the history of the program, we've until this flight, we had not been without all 3 computers for any length of time. We've had the last one fail and it reboot and bring them all back in the set, and that's a pretty, that happens pretty quickly. We don't really know, I mean, it occurs, we know it occurs, but if attitude control's being handled by the Russian segment, it picks back up with attitude control and we don't have to do much. So it's not insignificant that we've had 1 or 2 down. What is significant is that we've been without all 3, which we haven't been until this flight. This is the first time we've spent a long period of time without all 3 computers, and certainly without all 3 computers on both sides.
Todd?
Yeah, Todd Halverson of Florida Today. I was wondering, I don't think you answered the one question about whether there were any spares on board in terms of these command and control or GNC computers on the Russian side. And I was also wondering if you can't get them fixed, you stay in this exact same configuration and the shuttle has to leave. How long can you hang around without a propulsive capability up there?
Let's see, I'll answer the first one. I don't know. I haven't asked if we have spares, but I will tell you our Russian colleagues typically have a spare for everything that's on orbit. Again, you don't need all 3. The job can be done with 1. So from our perspective, if they have 2, they have 1 spare and 1 computer. So, but I haven't asked that question specifically, so I don't know if we have a spare in addition to the 3 that are in the 1 set. The other question, it's hard to answer right now. If the first thing that has to happen when a shuttle leaves is we have to handle the transient of the shuttle departure. Typically that requires a desaturation, requiring thruster control on the Russian segment. So the very first thing we'd have to do is figure out how to deal with a departure. So, I mean, immediately we'd be trying to figure out how to keep the vehicle stable without propulsive attitude control.
Mike.
Hi, Mike Schneider, Associated Press. Question for John. If you could just explain the rationale for choosing the 3rd spacewalk instead of the 4th spacewalk for the blanket repair.
Well, see, we talked it through for quite a while, and if you remember, I told you yesterday that the team had pretty much 100% consensus that we needed to do a repair to prevent any damage to the flight hardware, and we talked about it. It fit in either EVA, and after discussing it for a while, we kind of came to the point that this is something that we need to go do. It's a pretty high priority, and we would hate to pass up an opportunity while we're EVA to go do it. And the ops team is pulling together all the procedures and the training required for the crew on orbit, and I expect that they'll be able to make the Friday EVA. If they don't, or if they run into some kind of a hiccup, or the crew is busy doing something else, then the team would be very comfortable doing it on EVA 4. But we just thought the first opportunity was a good one, and we'd like to take it. It also it provides 2 additional things. It's 2 less days that you're flying around with this blanket that's up, and the other one is if something doesn't go right on EVA 3, you've got another chance on EVA 4 to do it again. So that was kind of the rationale that went into it.
It's late, so we're going to take about 1 or 2 more questions. Mike, did you have a follow-up?
If you all decide that the shuttle should stay some extra time at the station, how many more days past what is now, I guess, the undocking day could you all stay up there?
Well, 1 is easy. If you remember, we just extended by 2 days our docked time frame, and the limiting consumable for me is cryogenic oxygen, which feeds the fuel cells, which provide power to the shuttle. And I had 18 hours of cryo for feeding those fuel cells above the 13 plus 2, which that's my 2 extension days for weather, for landing. 18 hours is getting pretty close to 24. We were supposed to provide 40 pounds of oxygen to the ISS, and we were going to do that on flight day 7. We decided at the MMT today to wait until flight day 9, I think, and Kelly can correct me if I'm wrong, to transfer that to ISS. And if it turned out that we needed that extra dock day, we'd just use that 40 pounds, and that would just about give us an extra day on orbit. If you were going to go past that one additional day, past next Wednesday, then you talk about eating into your contingency days that we typically use for landing weather problems. So that would be a much more difficult decision.
Jim and Tarek, and then we'll call it a day. Jake.
Hey, actually, for Rob, do you have any kind of training materials or pictures of these computers that we can get overnight?
We'll search for the computer pictures. Nothing readily available, but we'll take a look.
It'll be gray, a box with big connectors on the outside.
And it says Avicii Sleeping Machine. Yeah, okay. In terms of EMI, I just chasing down EMI comes to one of my nightmares. And have you looked in terms of external EMI? Have you had experience in the past on ISS, for example, of getting a reaction from ground radars that may be pulsing you at high power? There are some new ground radars out there in the past 6 to 12 months that I've been watching the station, and I don't know if have you seen anything like that?
Well, I'll tell you that we're looking at all sources, including external sources, and they can come from off of the planet as well as on the planet. So we'll look at all sources of any sort of radiation that might be occurring on board ISS.
And finally, Tarek.
Thank you. Tarek Mack with Space News and Space.com for Kelly. I just kind of had a question about how the station crew is working through this problem with the folks at Russia's MCC. I mean, how much work do they have to divert because they are handling the computers? I guess what's the impact to them personally?
Actually, it's been very little impact in terms of the mission. We've got a very well integrated crew, and so while the shuttle crew has been busy with the spacewalk today, we did have the station crew who was able to work with Moscow and help them out for power downs and different activities. So it's been a very, just an excellent crew working together to get all the things that we need to get done to get finished. So it's went really well.
Okay, that'll wrap up the questions. We're going to get the briefers out immediately because they still have a lot of work to do tonight. Just 2 quick programming notes. Shortly after the briefing concludes, we'll be broadcasting the video taken by the cameras on Atlantis' solid rocket boosters during its climb to orbit last Friday. That'll be on NASA TV. Our Flight Day Highlights package, where all of the video from today's activities will be broadcast on NASA TV at midnight Central Time, 1 a.m. Eastern Time, and replayed throughout the crew's sleep period. With that, have a good evening, and we'll see you back here tomorrow. Thanks a lot.